The remote area of Tin Shui Wai in Hong Kong's northwestern New Territories has long challenged the resourcefulness of its villagers. In a low-lying silty area suited only for farming carp and mullet and for duck ponds, men have built and managed a complex network of embankments and sluices, ingeniously wresting a living from unpromising surroundings. Nothing has ever been known to change life significantly here, but the area is far too poorly drained and flood-prone to admit of any important development. Elsewhere, acute land shortage has meant that massive housing projects for Hong Kong's 6 million people have had to be built on reclaimed land. In the New Territories, new towns like Sha Tin have already sprung up to replace older communities. Yuen Long lies to the east of Tin Shui Wai, and yet another conurbation, Tuen Mun, is just to the south. Tin Shui Wai is at last seeing change. Over a 450-hectare site, granular fill taken from the seabed to the south is being deposited with precision, obliterating the old fish ponds and raising the level to an average of 5.5 meters above principal datum. The contract is a joint venture between Bilfinger and Berger and China State Construction Engineering Corporation. Tin Shui Wai will become a major urban area, with the first 30,000 people settling in by 1991, and an eventual population of 140,000, enjoying modern amenities. The scheme calls for an overlay of marine mud to be dredged away by the trailer hopper dredger Wiesbaden, revealing the granular fill in the seabed. The dredger Gotland wins this fill for barging to the Bilberg 1, a cutter suction dredger. The barges travel 12.5 kilometers up the coast to a rehandling basin formed in the seabed. From there, the fill will be pumped by the Bilberg 1 to the site. The work to modify the Gotland for the Hong Kong contract was undertaken in Holland. Bilfinger and Berger installed a 10-meter wide device known as the dust pan. This is lowered to the seabed, where its powerful water jets loosen the relatively compact granular deposits. The dust pan, which explores the deposits horizontally, is an innovative solution to the dredging problems involved, and it's the first time it has been used in a Hong Kong operation. Work on site in Hong Kong is also well underway. The ponds are dewatered, draining away to the north. New land will soon appear, formed as the sand, mixed with seawater in a proportion averaging 1:4, is pumped in. Just as the marine surveys have mapped out the ancient deposits which are to renew this land, so the land-based teams survey with great precision the old fish ponds, charting their depths, their retaining bunds, and their trackways. The vast quantities of data which are gathered have to be inspected and modelled using computer algorithms to provide electronic maps and sections of the site. This MOS modelling, as the particular computer package is known, allows the engineers to produce the required drawings very quickly, and also allows them to exercise stringent quality control over the whole operation, using online methods. The fill can thus be produced and placed exactly as required, at the optimum speed. Ponds may have died to their old use, but the soil from the bunds is conserved on tips that will eventually supply topsoil for the parks and public gardens of the new town. A causeway has been built as part of a land access corridor over 1,000 meters long. It is down this corridor that the pipeline delivering the fill will be laid. The land access corridor, like the entire scheme, is part of a design that seeks to disturb the surrounding environment as little as possible. The scale of the project can be sensed from the fact that two of the ships involved in the dredging, the Gotland and the Neuland, were themselves shipped out to their workstations. The two dredgers' journey from Holland to Hong Kong lasted a month. They were transported on a dock lift vessel, which also had on board the 12 kilometers of pipe sections and the massive booster pumps, each weighing some 100 tons. The Wiesbaden has an important role to play. Some 30 million cubic meters of marine mud must be moved before the Gotland can get at the fill. The Wiesbaden systematically dredges the exact site of the spots selected by Bilfinger and Berger from the proposed borrow areas. She trails a suction head along the bottom. The mud is dredged by means of suction, and the Wiesbaden then heads for an area south of the island of Cheung Chau, some 50 kilometers away. High above the roar of the machinery on board, the pipe operator controls events deep beneath the surface. As the mud is sucked on board, a continuous plot of the Wiesbaden's direction and speed is traced out. This plot provides the dredging engineers with an exact profile of the progress she is making in removing the varying depths of marine mud, shown in different colors. Off Cheung Chau, the Wiesbaden deposits her load of mud by opening valves in her hull and starts back north for the next cycle of dredging. Off the end of the causeway, another seabed excavation is underway. This is the formation of the rehandling basin, into which the fill will initially be placed. It is essential to have this basin if the fill so carefully won and sent up the coast by barge is to be optimally retrieved by the Bilberg 1 for pumping ashore. The barge train itself must operate within the confines of a specially dredged channel now being prepared. Dredgers come in all shapes and sizes, and each one has its own characteristic mode of operation and special application. The type of dredger that perhaps evokes the most nostalgia in the heart of the experienced dredging man is the bucket dredger, with its simple principles and sturdy machinery. The dredging crews on all these vessels, as indeed all the engineers from the company, can expect to work 12 hours a day, 7 days a week for 3 months at a stretch. Such is the pressure to keep the operation going at maximum efficiency. The same pinpoint accuracy that maps the seabed and its reshaping operates above the surface to ensure that the engineer in charge of the dumping of fill by each barge will eventually be able to position each one exactly where the Bilberg 1 wants the fill to be. Poles with site markers on them are placed in the rehandling basin, and these are sturdy enough to moor the Bilberg 1 by means of wires. The site markers will help guide the barges into position. By now, the dock lift vessel, with its massive cargo of machinery, pipes and 2 dredgers, is lying just to the north of Hong Kong's largest island, Lantau, not far from the site where the Wiesbaden is dredging the unwanted marine mud. It will take 3 days to unload the land-based equipment that she has brought with her from Holland, but a mere 2 hours to flood her sufficiently to allow the Gotland to float free from her deck. The whole operation marks another first for Hong Kong.
Oké, ik denk dat ik ze maar via de tunnel laat gaan.
Back on land, the pipeline is rapidly taking shape. Specially trained fitters and welders assemble the strung-out sections into a continuous line that will deliver an unending stream of fill for more than 2 years. Throughout its length, the pipeline will be subject to abrasion from the sandy fill, and this means that the pipe sections will gradually wear away, bottom first. The sections can be turned, each one at least twice, to even out that wear. But eventually the monitoring program will dictate that they have to be replaced, and this must be done with a minimum of interference to the filling. The booster pumps are placed into the line in series. These pumps build up the pressure in the pipeline that is required if the fill is to be delivered to the southernmost areas of the site, a 6-kilometer journey. The pumps are surrounded by special sound-reducing housings as part of the noise control measures exercised on site. Both pumps, rated at 3,600 horsepower each, will be needed to produce the pressures required initially. But by the time the fill is travelling only to the nearer northern sector of the site, one will be sufficient. In Deep Bay, the Bilberg 1 arrives under her own power. She is carefully manoeuvred into position at the rehandling basin. She will be connected directly to the marine end of the 800mm diameter pipeline. This means that some sections of the pipeline must be floated and given flexible ball joints to absorb tidal and wave movement, and to allow the Bilberg 1 to be readily repositioned. The last link in the chain is now in place. The Bilberg 1 is now moored to the poles with their site markers. The whole rehandling basin is only 400 meters square, so there is no room for conventional anchors. Not only is this particular part of the site very restricted, it is also subject to further environmental controls. To the south, the granular fill has been exposed by the Wiesbaden's dredging. It is now the task of the Gotland to win this fill from the seabed at depths of up to 44 meters. The massive dust pan acts like a precision vacuum cleaner. Its angle and depth, as well as the exact status of the whole operation, are constantly monitored and controlled by computer-assisted techniques. The Gotland is anchored by up to 6 anchors. As the dredging proceeds, she moves forwards and backwards. The sand that she agitates with her pressure jets is sucked up and pumped into the barges alongside. Each of the barges on the project takes between 15 and 20 minutes to load, the sand sinking gradually to the bottom of the well. Each barge is loaded through a spreader pipe, which distributes the fill evenly over the length of the well. Survey work continues as the dredging proceeds. Echo-sounding transducers map the changing contours of the seabed. The tugs take the filled barge off and into the barge train, which goes up the coast to the rehandling basin. The largest of the barges used on this contract have a capacity of 1,000 cubic meters. They are split barges and are known as push barges, for they have been specially modified for pushing by the tugs that take them off into the train, which is made up of 10 barges altogether. Each barge is carefully maneuvered to its correct dumping position in front of the Bilberg 1. Whereas the doors of the older type of barge operated by means of chains, these split barges are hydraulically operated. The rehandling basin is divided into sections, each of which is filled in turn in readiness for the dredger to recover the fill later. The Bilberg 1's cutter suction head moves through an extensive arc to dredge the contents of the sectionalized basin. This movement, like the whole operation, is supervised from a central computer-assisted control point. Everything is controlled by the one operator, although naturally he is supported by a deck and engine room crew. The head, at the end of its long ladder, sweeps across the fill. On-board winches pull the Bilberg 1 through the arc, paying in and out the wires which moor her to the poles at the side of the basin. The Bilberg 1 can dredge to a depth of 25 meters. The cutter and submerged pump are together rated at over 8,000 horsepower. The two delivery pumps are together rated at 10,000 horsepower. The total installed horsepower of the Bilberg 1 is 22,000. The forward movement of the cutter head is achieved by advancing the vessel. A Bilberg 1 has two 120-ton spud poles, steel legs that pin the dredger to the seabed. When the vessel is dredging, the spuds can be hydraulically raised and lowered to move her forward. The working spud on the center line at the stern is lifted, and the helping spud on the starboard side is lowered. The working spud then moves to its new position, fully retracting the hydraulic ram along the center line. The working spud is then lowered, and the helping spud is raised. Each such step enables the Bilberg 1 to advance a further 6 meters. June the 1st, 1988. The mobilization and installation is complete. The months and years of meticulous planning are crowned with success as the first fill begins its 6-kilometer journey to the site. But the transformation of Tin Shui Wai's fish ponds into solidly compacted and well-drained building land will take more than 2 years to accomplish. Placing 20 million cubic meters of sand at a rate of 12 hectares a month will demand the deployment of Bilfinger and Berger's full armory of dredging expertise. The Bilberg 1, Wiesbaden and Gotland will be joined by other equipment using different techniques for winning the sand. The borrow areas of Urmston Road and Deep Bay are difficult and restricted. Dredging conditions vary widely in a small area. Constraints are imposed by the requirements of shipping in the vicinity. The pumping of the fill presents problems no less than its winning. From the delivery pumps on Bilberg 1, through the floating pipeline and the boosters, along the 800mm land lines to the 600mm outfalls at the site, pipes and equipment will be tested unceasingly to their limits. As the months pass, this wear and tear will become significantly greater than had been imagined. Sand is the enemy of machinery. Traveling through pumps and pipelines at an average speed of 7.5 meters per second, the sand and seawater mixture has a destructive capacity which is impressive. The property of the sand, which is absolutely crucial, both to its value as fill material and as an indicator of probable wear and tear, is grain size. Every day, core samples are taken on site. By a series of sieves, the constituent grains are batched into different sizes, their weights and dimensions being recorded on a log sheet. These results, when collated and put into the computer, provide guidance in repair scheduling and production. The pipes delivering the fill are also monitored regularly. Wear in the pipes usually starts bottom first, due to the effect of gravity. So the maximum life of the pipe section is obtained by rotating it 3 times through 90 degrees after the initial wear has taken place. Ultrasonic testing shows the pipe's thickness. This vigilance is essential to detect flaws before they become critical.
Hallo Bilberg 1, hallo Bilberg 1, hallo Bilberg 1.
A defect is discovered in a pipe section.
The foreman on site alerts the dredge master on Bilberg 1 so that the throughput can be shut down while the pipe is changed. Wear in the pipe is not just a matter of gravity. Extra wear can be caused by larger grain size or by increased mixture velocity or density. Then there is turbulence. In a spiral welded pipe, the weld seam can create a vortex effect. Indeed, any protrusion inside the pipe can cause wear resulting from asymmetrical flow patterns. Angled sections are particularly vulnerable, and they cannot be turned. Pipe wear is more severe in those sections immediately downstream of the delivery and booster pumps. Frequent pipe rotation and replacement are therefore required in the floating sections next to the Bilberg 1. Where possible, maintenance work on the pipes is timed to coincide with repairs to the Bilberg 1's delivery systems, so that production downtime is kept to a minimum. The pipe sections removed are not junked. It may be possible by welding or by the addition of an outer sleeve to a worn pipe to prolong its use. 25mm gauge hardened steel pipe shipped from Europe is not an expendable commodity. At Bilfinger and Berger's workshop on the Tin Shui Wai site, pipe sections, flanges and joints taken out of service are examined to find out whether they can be repaired. Here can be seen in full measure the destructive effects of sand and seawater.
Yeah, see you. Yeah, you can nothing do about this, I think. It's completely weighing here. Yeah. Over there also. Yeah. You see? Terrible.
In Urmston Road, sand recovery is boosted by a suction pump unit. This unit, called Amix, is a local A-frame barge with a 750 horsepower underwater suction pump suspended from its derrick. The sand and water mixture is delivered from the seabed by a flexible hose to the loading system. This economical addition to the dredging fleet was very quickly put into operation and saved the expense of bringing in new equipment from Europe. In Deep Bay, dredgers Badu 1 and 2 win the sand by penetrating a thick overburden of marine and alluvial clay. The Badu system drill bit, when submerged, employs flushing jets to clear the borehole of mud and debris. When sand is encountered, it is agitated by jetting water and airlifted in suspension up the drill pipe. The drill's descent through the clay layers is governed by a rocker device. The rate of penetration of this equipment and the pressure on the bit is monitored and adjusted in the control room. The airlift system works by differential pressure between the aerated water inside the drill pipe, which carries up the sand, and the surrounding seawater. Its efficiency is the same at all dredging depths. Clay layers too tough to be removed by trailer hopper dredgers can be penetrated with comparative ease, and the minimal number of moving parts in the sand airlifting system means far fewer problems of wear and tear. When the sand layer is reached, the loading pipe is connected and loading proceeds through the spreader pipe to the barges. The procession of barges to and from the rehandling basin is never ending. On the Bilberg 1, the lights go on. For Hong Kong at large, it's dinner time, cinema time, late shopping time, going out for a drink time, Here, it's pump overhaul time. Every 6 days, the Bilberg's inboard dredge pumps must be shut down for maintenance, and smaller components such as wear rings and liners replaced. The larger wear parts, such as pump housings, have to be changed every 3 months. The inner shells of these double-wall pumps suffer considerable high-pressure damage, and Bilfinger and Berger have developed their own welding techniques to cope with this. The impellers are replaced at 10-week intervals. When pumping, the impeller edge is cutting through a sand, gravel and seawater mixture at 90 kilometers an hour. This velocity and the grain size are the factors mainly affecting wear and tear in the other pump components. The rate of wear can be almost incredible. At points of high stress, hardened steel can be eroded by 40 millimeters in 6 days. The Tin Shui Wai contract has presented Bilfinger and Berger with every conceivable dredging problem. A site with an underlying weakness, borrow areas of widely differing conditions and dispersed locations, and wear and tear on equipment which reached undreamed of levels. But these extreme difficulties were met and overcome, and this experience of research and development running in parallel with the job itself has turned out to be of inestimable value to Bilfinger and Berger. So week after week and month after month, the cycle of repair and renewal continues. On the Gotland and the Neuland, the Badu 1 and 2, on the Amix and the Bilberg 1, the shifts change over, 12 hours on, 12 hours off, 7 days a week, 52 weeks a year. And the river of sand keeps coming, dredged up by dustpan and suction pump and airlift. The borrow areas are combed and quartered to yield up the landfill material that will in due time support a city. On site, the fish ponds have nearly vanished under the advancing tide of sand film. Now the surveyors take their measurements to determine when the sand level will attain its required height of about 5.5 meters above principal datum. For when the site reaches that level and has stabilized, the job will be over. 480 hectares of prime building land, reclaimed in little more than 2 years. Reclaimed at a speed unattainable with more conventional landfill methods, and with minimal environmental disturbance. Already the piles are being driven for the first of the Tin Shui Wai estates, and among the coppices of steel can be seen the emerging foundations of the tower blocks. In 1992, Phase 1 will come on stream to become home to Tin Shui Wai's first 30,000 new inhabitants. As they collect their keys and move in their belongings, they will have good cause to thank the resourcefulness and engineering skills of Bilfinger and Berger, the active support of government, and the loyal service of workers at all levels that have contributed to the success of one of Hong Kong's most imaginative civil engineering projects.